Hello there, and then welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. Now, in this lesson, I'll be explaining some shading concept that will eventually lead us to understand what the De Morgan's laws are. So, without much ado, let's quickly look into it. Now, as you can see on the screen, I have a Venn diagram. The black box being our universal set, and we have set A and then set B as well. So without much ado, let's start with our shading. First shading we want to do is to shade A prime, that is the complement of A. The complement of A simply has to do with anything at all that is not in A. So let's shade all these regions over here, you see. So all these regions are going to be my complement of A. So any region that is not in the circle of A is a complement of A. So we are shading all that. Okay, so with that done, we now want to look at the complement of B. The complement of B. That is all the sets that are not in B. Once again, that are not in B. So this is our B over here. And we want all the elements that are not in B. So I'm going to shade that red as well. So first of all, I want to take my time to shade the circle around the circle so that I don't end up shading any element in the circle. So this is what we have, just as we did for the A. I just want to take my time. Okay. Now, if you are also doing it, then you take your time and then do your shading properly. Now, if you're able to do it, you'd have something like this. You remember the colors we use for the shading? We use red and a green. You note that one part of it, we can now see, let me see, we can see the green, we can see a white where there is no shading at all, and we can see a red, and then we can see one other aspect. I would say it is a brown. What does this brown represent? What does this brown represent? The brown represents the intersection of the A prime and then the B prime, the complement of A and the complement of B. That means that when we're coloring or when we're shading the complement of A, it has a portion of the brown, and the complement of B also has a portion of the brown. You see, so what I'm going to say is this brown region here, I'm going to call it A and A prime and B prime. You see, so it is a portion that has both the complement of A and then the complement of B. Now that is settled. Another thing, another shading I want us to do is, let's take the union of A and B. So this here is the union of A and B, right? But we want to shade all the regions outside the union of A and B. Take note, all the regions outside the union of A and B. How do we do that? So let's do that together. I'm just going to make sure my shading does not include the union of A and B. So you can do that on your own as well. Do it gently. And then if you get your target, you can now go all out. So as you can see, I just want to shade the borders as well. And then now I can go all out. Now, the shaded portion here is my A union B complement. That is the elements that are not in A union B. Do you see? So let's write that down. So we are going to call it A union B or prime. A union B or prime. Now, let's compare what we have in this first one here, and then let's compare what we have also in this second one. Do you see any difference? That is talking about the shaded region. The shaded region. So in this case, we are talking of the brown side over here, and then in this case, I'm talking of this pointed side over here. Do you see any difference? There's actually no difference. That gives us the first law, the first De Morgan's law. So what De Morgan's first law says is that if we have A union B or complement, it is equal to A prime intersection B prime, as our Venn diagrams have shown over here. So in words, it says the complement of the union is the intersection of the complement. You see how nice it is? The complement of the union, you see, the complement of the union of the two sets is the intersection. This is our intersection. So the intersection of the complement. Very simple. This is the first De Morgan law. Now let's look at the second one. And as we did for this, we would go and then represent on the Venn diagram so we can understand as well. So for the second law, what we want to shade is A prime all together with B prime. You see, so you are shading A prime and then B prime all together. We are doing all simultaneously. So first of all, let me start with my A prime. So I would target all the spaces I have on A. You see, so if I continue over here, I'll get all my A prime. Then I also want my B prime. So all the spaces, so including here is my A prime. Now for my B prime as well, then if my B is circle, is the, what do you call it, the red circle, then it means this side will also include my B prime. So I'll shade that as well. So this simply means that the only unshaded region is going to be the intersection. You see, so my only unshaded region is going to be my intersection. So let me shade everything all together so that we can see it clearly. If you're also doing your shading, that is nice. So we have all of this over here. Now, as I said, the only unshaded region was the intersection. And what is the name of our shaded region this time? This time around, it is the union of A prime all together with B prime. We did all that together. I hope that is clear. Okay. Now, in our next Venn diagram here, we want to target the intersection of A and B. So this here is the intersection of A and B. Now, as we have targeted it, what we want to do, we don't want to shade that particular side. So we are shading the whole Venn diagram, excluding the intersection. You see? So let's do that shading and see. So as you can see, I had to pause and then do it so that we don't use much time. Now, the shaded region over here is going to be labeled as the element outside the intersection of A and B. You see, so we targeted A intersection B, we didn't shade, but then we shade every element outside of it. What do you observe here? The first and then the second one. You realize that they are the same. You see, they are the same, they've shaded the same region, but their names we used were different. This takes us to the second De Morgan's law, law 2. And law 2 says that the complement of the intersection is the union of the complement. What does that mean? So this is the complement of the intersection. These are the intersections, you see, and we have taken their complement. It is the same as taking the union of the individual complement. You see, So these are the De Morgan's laws, and we have used the Venn diagram to prove them, and I do hope you understand. Now we would want to solve these questions to enhance our understanding on the De Morgan's law. We have a universal set, and there is set A and then set B, and we have to show that. So these are actually the De Morgan's laws. We want to show that they are true. So how do we go about it? First of all, let's start with I. Now for I, we want to prove that A union B prime is equal to A prime intersection B prime. So the first thing we need is our A union B. You see, so A union B simply means all in A plus all in B. And we avoid repetition. So we have 1, 2, 3, 4, and 5. You see, because we have 1 here, there is 2, there's 3, there's 3 here. We don't repeat them. We just write one of them. 4 and 5. But what we actually want is the complement. So A union B prime. So we go back to the universal set and then look at all we have in the universal set that are not in A union B. And looking at it critically, you realize that it's just 6. It's just your 6. You see. Then let's come to A prime. So we already have our A over here. Then our A prime simply means the elements in the universal set but not in A. So we have 1, 2, and 3 all being in what? A. Hence, what we don't have in A are 4, 5, and then 6. You see. Then for our B prime also, we are looking for all the elements in the universal set that are not in B. So there is 3 in B, there is 4, and then there is 5. So what we don't have is 1, 2, and 6. But with that said, it is intersection we want. So it simply means that A intersection B prime is going to be, what do they have in common? You realize that it's just 6 they have in common. So it's 6. Now, if you are to call this our left hand side, because it is at the left hand, and we call this our right hand side, then looking at them, you realize that they are actually the same. The left hand side is giving us 6 as the element in the set, and the right hand side is also giving us 6 as the element in the what set. So this implies that what our A union B is actually equal to A union B or prime is actually equal to what? The intersection of the primes. Hence what? Proved. Simple. DC. Now let's look at the second one as well. So for the second one, we actually want A intersection B or prime. We want to test if it is equal to what? A prime union B prime. So first of all, we look for our A intersection B. So our A intersection B has to do with what is in A and also in B. You realize that it is just our 3. So we have our 3, but we want it prime. That is it complement. So our A intersection B complement simply means we have to go to the universal set and look for what is in the universal set but not in this set we have written. So it is obvious that apart from the 3, any other thing has or have to be written over here. So we have our 1, 2, 4, 5, and then 6. Then we come to, so this here is going to be our left hand side. For the right hand side, we want the complement of A prime. And as a matter of fact, we already have them over here. So we have the complement of A prime and the complement of B. Sorry, the complement of A and then the complement of B. And if you want their union, then we are going to say A prime union B prime is going to be equal to 4, 5, 6. So if you want us to write it in order, then it's actually a 1, 2, 4, 5, and 6. Now, if you look at the above set critically, you realize that they're actually the same. You see, so we conclude by also saying that comparing the left-hand side to the right-hand side, it simply implies that what our A intersection B prime is equal to the intersection, the union of the complement, hence proved. You see, very simple. If you want to actually use sets to show, then you would have to take your time and list out the elements in the sets. This is how far this video is going to go. I'll leave some exercises for you to try on your own to test your understanding as well. So this is the question you can try on. It says set U has elements 10, 20, 30, and then 40, and then X is 10 and 20, Y is 20 and 30. Find X intersection Y or prime. Then they are very simple. The next one says which De Morgan's law states this, and then you have to find the set as well. This is how beyond numbers. If this is your first time on this channel and you think it will be helpful to you, you can subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now.